Hello viewers, welcome back to video tutorial on AgentGrid. In this video tutorial series, we are demonstrating various agentic patterns possible with our open source AgentGrid SDK. So far, we have given separate videos on sequential pattern, conditional sequence pattern, parallel pattern, router pattern, and orchestrator pattern. And currently, we are in a human in loop pattern. So let's get started with the human in loop pattern with open source AgentGrid SDK. So here, whenever we are explaining with the different patterns, we are taking certain application in mind and then we are giving the walkthrough. So in this video tutorial, we'll be discussing a movie recommendation and booking flow where several agents will collaborate to provide an options to the user, and with the human intervention, the final selection will be done via UI interface. So that's why we call it as a human in loop agentic pipeline. So to know more about AgentGrid and AgentGrid SDKs, you can click on the links here, and to know more about agentic patterns, you can click the links here. You have video, blog, and agentic pattern. The documentation as well, different agentic pattern documentations. So let's start with our case study, movie recommendation with human in loop. Human in loop pattern integrates human judgment into an automated workflow. This is a case study where agent handle the data gathering and filtering. Basically, the sub agents will do this, but the final booking will be done by the human itself by giving a final decision from the human. So we have a planning agent, a movie planner agent, and who analyzes the user request and delegates the task to a specialist agents. So a user request will come to the movie planner agent, and it will delegate some instructions to the sub agents, specialist agents, and also it will communicate, because since we have multiple agents in between, we want something known as mux operation, fan in operation. So we have to inform the last guy, the synthesizer agent. Basically, hey, you have to wait for two different agents input. So that communication, this movie planner agent will take care of communicating that details to the last agent, the synthesizer agent. So we have a parallel retrieval. Basically, we have a calendar agent and a preference agent, where the calendar agent will check for the user availability and also matches the history of user watching movies, meaning user has watched several movies. That history is also available in the calendar agent's access, and also users availability, what is the free slots of a user available for this week or next week. That details also will be available with the calendar agent, and with that details it will churn out the data, like which can be the probable preference timing, movie watching time from the calendar agent. Whereas the preference agent, it tells about the movie taste, what user has watched, what user wants to watch, what user doesn't wants to watch. All those details and special instructions will be curated by this preference agent from again certain histories or the calendar details or some user instructions, and those two details will be sent to the final aggregation or a synthesizer agent. We call it as a book my show agent, which acts like an aggregator, matches this the time slot, the freeze time slot, and also the movie preferences. And also this will have access to what all movies are available in which all theaters. It's like an aggregator, movie aggregator platform kind of thing. So it will take care of matching. This agent will take care of matching all those details, the calendars, the preferences, and also the movie availability in the theaters along with its show time. So at the end it will match, and it will provide certain suggestions to the user, and user will make a final selection. So to do the suggestions, we are using a human intervention system from AgentGrid platform, and the human intervention service which will post the options to the dashboard. We're a simple Streamlit based dashboard we have used, and from the dashboard we'll give a feedback, and that will go back to the again the book my show agent, and to give the final user's choice. So right now we are not integrating with the calendar app or any other apps. We are just trying to mimic those details using certain YAML file concepts, and also we are not integrating with any aggregators, movie aggregators platforms. We are just again showing everything detailed with the mimicking data. So a final selection will be done at his side, human intervention system side, and then agent receives the choice and completes the So the booking part we have not dealt, so it is just for a showcase purpose. So this is the whole architecture here. We have movie planner, movie preference. They'll work in tandem, parallel, so that they will provide their information to the final agent. Final agent will talk to the human in loop component, and user will it will go to the user's confirmation. I mean, user will know, it will get notified to the user. User has to again give some confirmation that will be picked by this book my show agent, and it will give the final confirmation. So human interventions integration code, it looks like this in our code. I'll explain again in the code. So we require on his client human in human in loop client code. We have a class file here. So we need to create the object first by giving certain base URLs, and polling interval, how frequently we need to keep polling, and what is the maximum wait for the polling. So if you are not pressing anything within this maximum wait time, then his client will time out, and you will not get the response. So we have to make sure that proper good max wait time we need to provide. And in the onData class, basically we will do an submit and wait function. We'll call the submit and wait function, and we'll provide some user the data that user wants to see. Basically we are giving hey, choose your movie options. We are giving the all curated movies, and also we might give some reasonings, like what all reasons went through before giving the final list. So those reasonings also will be provided here. And in users, whenever user presses something, like user selects some movie, it will come back to the again this particular movie planner book my show agent, and to get that details we will just do the response or obj.response data.get user choice. So user choice has to be sent from the dashboard side or a user interface side. So user choice raw will come here, and again we can use that to finalize our bookings. So we have a orchestrator, we have a calendar, orchestrator, the planner which acts like orchestrator here. So the code is a movie planner agent.py, parses the request, sets the strategy, and delegates the specialist. Whereas we have a calendar specialist, calendar agent.py, queries users schedules to find free slots, and a preference specialist where movie preference, it will identify the genres, movies that user like, movies that user wants to avoid, all those details. This agent will take care, and at the final is the aggregator, which has an integration to the his as well. So his is a human intervention system for finalizing human choices and finalizing. So we have provided a Streamlit app as well, so that we need to run it, so that we will get to know whenever the BMS aggregator wants to send communication to user, it will come in Streamlit app. Without Streamlit app also we can run, again we have to run something in terminal, so we are running it in Streamlit app right now. So right now I'll show you, like right now the Streamlit app will be running in 8051 port. So once I run that particular cell, you can see there's a particular app running. So so let me explain the code first one by one. So let me go to the planner agent, the first agent. So here is a planner agent signature with the DSPy signature. So you are a movie planner orchestrator. Analyze the user's request, identify which information is needed. Typically you need to check both users schedule, calendar, and their movie tastes using preferences. So user text will come here, and a brief plan of action is required, and also a calendar query and a preference query. Basically these are the instructions to the calendar agent, and these are the instructions to the preference agent, because the text can contain, hey, I want something on this day. So if that day is there, so you have to curate the query to the calendar agent. If that day is not mentioned, so again it has to curate the query to the calendar agent. So a specific instruction to the calendar agent to check availability, specific instruction to preference agent to check users tastes. So we have a DSPy module class, so planner module. It uses a DSPy chain of thought. So we have a variable on SL planner, which is an object of DSPy chain of thought. These are again same as explained earlier. A payload processor for parsing the input task, and a model context manager for managing the context of LLM for DSPy inferences. So we can easily switch between the third party like Gemini or OpenAI models. Also, we can switch between our AI voice based LLMs as well. So this AI voice DS by LM will help in that case. So we have explained what is AI voice DS by LM. It's a special class which will take care of all the three LLM platforms. One is AI voice, OpenAI, and Gemini. We can do an if and else conditions to handle other inferences as well, other platform inferences as well. So a movie planner agent, we have an agent config.yaml. It basically configuration. It is a YAML file which tells you who is the next agent for a given use case. Instead of hard coding the next agents in our code, we have just put it in a YAML file. Let's say a movie planner agent, it has two other agents in the next agent, whereas a calendar agent has only one agent, which is a book my show, and as well as the preference agent also has the next agent as a book my show. So that is which is nothing but a synthesizer. Book my show doesn't have any next agent. So that's why we are reading the agent config.yaml, and this we have already explained. We are initializing several objects. This is basically for a known agent selections. So what is known agent? It's a class which will help us in filtering the agents registered under the agent grid. So basically you need to add a query like metadata subject search tag equal to movie planner. So with this, whatever the agents, whenever we are registering an agent, if it has a movie planner tag, then those agents will be available in the known agents. So basically you are filtering all the available agents and you are collecting only the agents that you want. And you can get agent.id from it, and I'm putting it in all agents.ids. And now this agent search selector is a new the module that we have not explained earlier maybe, but yeah, I'll just show you. So we have explained to agent LLM, agents SDK, and right now it's an agent search module. So what this module can help us is to collect any agent details. So basically, let's say you have filtered the agents, but you want to select any one agent in that. So you can use this particular module. So we have agent search selector. So you just initialize it. It requires an inference server ID as well, and it requires the inference server registry URL and block DB URL. All these details will be provided during the registration time. So and these details will come from the one who has deployed the cluster, right? So they will be providing all those details. So that we are putting it in registry, and from registration we are giving it in agent selector. So here by default a default name is given. Any name you can give. So if name is not given, a default name will be chosen. So right now I have kept a name itself as a default. And now to query that particular agent, you have to use a function search from objects, and you need to give the name, which name you want to, like you can have multiple you would have registered multiple selectors. So in that, which selector to choose. So let's say you have one LLM for one particular you have registered one LLM for one registration selection, and you would have done one more registration for with a different LLM. So instead of giving again those LLM details, so you can use simply the names here. So I'm using the name equal to default. So and I have to provide all the known agents, so that will get it from the here. So the known agents now has all the agents which are a movie planner agent. And now you can give your query. Hey, I want a movie planner or orchestrator for movie planning. So such kind of a query string you can give. So that will find out of whatever the movie planner agents are there, right? In that, what is the orchestrator? So basically it's a movie planner agent. So that it can provide you as a chosen ID. So right now I'm initializing that to a chosen ID, self.chosen agent ID. And we have a function known as update mux size to aggregator. So as I told, we need to update the mux size right at the end, because the synthesizer needs to know how much input it has to wait from. So that's why we have a function. We have a function here, update mux size. Basically what it does is from the configuration, the config YAML dot the config agents config.yaml, you have told like it has two agents at the end. So basically I'll collect those details from the YAML files content, and I will just initialize mux size to a length of that, which is like right now 2. And who is the next aggregator? The aggregator agent ID is the movie planner book my show agent. So for that agent, I will send one piece of information, which is a mux size, which is equivalent to a value of 2 right now. And I can send it in delegate mode, I can send it in a P2P mode, or I can send it in a if and else condition delegated mode, P2P mode, and also you can do a direct mode as well. So I have not added it, but you can add it in a direct mode as well. So the once mux size is communicated, basically the last agent will know, oh, it has to wait for 2 contents, one content from the movie preference and one content for calendar agent. So that kind of logic will be explained in the book my show agent. So next, in on data function, so you have a prepare inputs. As soon as input comes, it will be broken, like it is a class of a agent task, so it will be broken down into the content that we want. Basically the text is required, communication types are required, right? So it will broke that agent task class to this kind of information. And executor worker, where we need to present the text and the model name. The executor work will take care of doing the inference. So given the user input, and it will take this signature and get these 3 output fields. One is plan, calendar query, and a preference query. And from the result, so we are calling update muxer. So mux size will be communicated to the last agent, the aggregate agent, and delegate task. So here in this function, so you know what all next agents. So basically I have 2 agents. One is a calendar agent and a preference agent. So for them I have to send the input in a for loop. So if it is a calendar agent, I'll use results.calendar.query, because this result is nothing but DSPy signatures content. Result.calendar query. If it is a preference agent, if the preference is there in the next agent ID, and then I'll use the preference query. If not, the text itself will be sent. So I can communicate this data with P2P and direct submit functions. So I'll give an instruction to the subsequent agents which has to run in parallel, and I'll give the instructions to them. So here the instruction is sent in a text keyword, and also original query is also sent. Original query is nothing but the user's input. So user's input and the instruction to those agents will be sent from the will be sent in the delegate task function. So a task will be delegated, and we are returning from this particular on data function. So this is the movie planner. It's not doing very complicated things. It just gets the query for sub agents, and also sends the data to those agents, and also updates the mux for the last synthesizer agent. So let's go to the movie preference agent. So for movie preference agent, so you are a movie preference specialist. Analyze the user's movie tastes, recently watched history, and special instructions. So as I mentioned, we are not integrating directly with any calendars or anything. So we have some YAMLs structure provided here. So this is the calendar preferences. So history of movie watch will be available here, and these are the preferences that user has given. And also we so this is the movie history that user has watched. The Avatar, The Way of Water, it is a sci-fi, watched during what time. So recent value will be available at the bottom, and special instructions also available. So basically these details will be collected by the preference agent. And also there is a preference genre, what genre a user is expected, must see, dislike genres, seat preferences, anything related to seats. Those details will be available here. Basically the preference agent collect all these details, and it will try to aggregate, provide the data to the last agent. So rules, exclusions: if watch history and special instructions imply a genre, it should be avoided. Like I watched thriller last week, explicitly list it in excluded genres. So structure, the structure is provided here: must see movies, excluded genres, and preferred movie genres. And special logic, exclude thriller due to recent history, kind of information you need to generate the output. So a query will be given. This query is a special instruction from the first agent. The preference data, so the static users preferences. This is watch history, again coming out of this YAMLs. And a special instruction, again it's coming from the YAMLs. All these are input fields, they are coming from the YAMLs. This is from the previous agent. and this is the output that we wanted, preferences summary. So module is initialized here. Again, we are using a chain of thought, DSPy chain of thought. Here also I'm using a agent search selector, but I'm giving a different query for identifying user movie taste and preferences. So this is my query. The LLM, this particular LLM will use this query with the help of the known agents, and it will select the agent ID. So there is no mux here, so I'm returning none. And in on data function, so I have a prepare input. Given the agent task input, it will break down that into a different the data like input text, raw preferences, watch history. So let us just check prepare input. So in the prepare input, we have a movie preferences.yaml and movie history.yaml. So movie preferences.yaml. Yes, so here what all genres you must see, dislike genres and seat preferences, all those details are available here. So that will be collected by this raw preferences and movie history watched. So again, it is a separate YAML. History, what all movie watched, and special instructions also available, so that will be collected. And history data, watched history and special instructions are curated here. So those things also will be returned by the prepare input function. And then execute worker. So we are passing those input text, the raw preferences, watch history, special instructions, and it will provide us the result. The result will have these three items. The preference summary will be only the result will have only one key, which is preference summary. So right now we are putting it in one package payload. So this payload has to be sent to the next agent, which is a synthesizer agent. So findings and the movie preferences. So raw this preference is from the this raw preferences, and these two values, findings and formatted preferences, again from the agent's output, so the LLM's output. And I'm doing the JSONification for that payload, and I'm putting it as a text key. So now this needs to be sent to the next agent. Again, who is the next agent? I'll get it from the agent's config.yaml, and I'll send it in either P2P or a direct submit communication. So the payload is given here, and I'll tell like session IDs, model name, communication, all those details I'll be telling it here. So this is about the preference. So preference basically collects all the preferences of the user and sends it to the next agent. The calendar agent here, it also has some work to do. You are a movie calendar specialist. Determine the best movie slots based on your user availability and historical preferences. Basically, you will have a user's availability, which is like a free time slot. It is of this kind of a structure, like Sunday, what all free slots available start and end, Monday free slots start and end. So every day, what all slots are available for this week, right? So that details will be available here. So you can replicate this for not just this week, maybe for next week. So that kind of details, instead of Sunday, Monday, you can give the date as well. And also you have a preferences here, like prefer Friday night movie slots after 1900. So maybe he's a working professional, he's not available until 1900 evening 1900. So Saturday afternoon or evening is also good. Do not recommend movies on weekdays, and also no movie watching on Sundays. So maybe no screen time. And also these are the history of movie watched. So what day and what time he watched the movie. It's not about genres or their tastes or a sci-fi movie or not. It's about the theater details and the time slot and the day. Those kind of details are available here. So basically we can pick the preferential time from this here. Let's say here like 1930 to 2030 and 16 to 18. So maybe user interested in evening time. And also we have a date here, Friday and Saturday. So with that we can calculate the user preferred timing. So we have populated very less data, but with more data, this can be a little bit more accurate. So yeah, you are giving some rules here. If original query contains specific days, let's say I want to watch a movie on Monday. If this is my query, so I have given Monday as an instruction, right? You must return all the free slots for those days from the calendar data. So if I mention it Monday, I require data for Monday only. If I have not mentioned what is like it's vague, I want to watch a movie on, I didn't say any day. So then you have to provide all the most likely days, plural, and time windows, most likely. So why it's most likely? Which user is preferring? Maybe since he is an working professional work days is not preferring, and only weekends he might be preferring, and also not on the Sundays. So source hierarchy, primary source, calendar data, only use time ranges from here in the final output. So basically calendar data, this is the final time slot. So these are the final time slots. So these are the previously watched movie time slots. May not be the, we should not return this, but this will just give you a hint that user prefers watching movie around this time. But this week, the free available time is this only. So at the end, we need to return these time slots only by this agent. So that's why we are curating the instructions for it. So secondary source, calendar preference, use only to select which slots from the primary source to include. So that's what some instructions related to that. And intersection calculation, how you have to calculate the intersection, meaning user here preferred time might be there and time slot might be there. Let's say this is a very broad window. So in that, how to find the intersection, those things we need to calculate. So for that we are giving an instructions here, step-by-step logic. So we have given some instructions here, curated, well-curated instructions. Multiple day slots. So sometime in a single day itself you might have a multiple days also you are okay with, like Friday, Saturday, so since Sunday is no screen time, so Sunday he will not, the agent should not select it. So multiple days also it has to select. Generally it might select only one day and it might give that one day. No, if multiple days are possible, you have to give multiple days, and multiple slots are possible in that day, multiple slots also it has to give. So that kind of instructions we are giving it here. So basically focused instruction, the instruction from the previous agent will be given here. Original query, like I want to watch a movie, this is the original query. The calendar data, the calendar preference, and the output fields are chosen days, formatted availability, and refined slot JSON. So here is the JSON content and here is a formatted text. The formatted availabilities, JSON data will be available in this field. So this is what we want from this agent. So again, DSPy module, calendar module is there. We are using a DSPy chain of thought again, and so rest remains same. I will not explain again. So here even the agent search selector is there. We are providing for checking user schedule and calendar availability. So this is the query string. The LLM will take action by selecting the proper agent which is in the movie planner tag. So that will update in the choose an agent ID. So again, in the prepare inputs, we are using movie calendar.yaml and calendar preference.yaml. From this, we are trying to collect the free time slots and the movie preferences using the history of movie watch. And we are just returning that data to the in onData function. So in onData, we are calling that prepare inputs, and then we are giving it to the LLM. LLM will bring 3 outputs. The chosen days and 2 more outputs. So from that I'll mention chosen days, formatted availability, and refined slots, and this I will send it to the next agent. So with the payload structure of this, findings, calendar slots, formatted availability, I'll do a JSON dump operation and then I'll send it to the next agent. So this is about the calendar agent. So next is a movie book my show agent, which has a few which has a signature, which has a muxer as well. First, the muxer I will not explain again. So basically n is dynamic, and here I am curating it like task ID versus n. Say if 2 multiple users are communicating simultaneously, it should take care of what is a task ID and what is a n. So for that reason I have kept task ID versus n, so that the muxer will not mix and match the user 1's calendar with user 2's preferences, right? So it should not mix and match. So it should hold it properly. So that's why we have a task ID versus n. Basically if mux size is key is present, so we are setting the n value. If not, it is defaulting to n equal to 1. And if mux size is present, so mux size key is present in the input, then we are setting up the n value. If mux size key is not present, if text is present, then we are appending those as a new array here. So anytime you get a text, right, we'll be keep on appending it. And whenever the size that will reach to the task, it will reach to the value of n, then we are returning that the whole task that we have collected so far to the code, and that code will take care of running that task with the LLM. So whenever we return that value, right, so whenever we return the collected packets, we have to delete that as well. So that's what we are trying to delete here. And so that's it about this muxer here. So it is basically trying to handle all the boundary conditions, edge conditions is handled here in this muxer. And this muxer will be taken by the core.main main function is there, right? So it will be using this muxer. So whenever input is received, it will call the add muxer.add, and it will give the agent task. And muxer, if the mux size is present, so it will update the mux size and it will return without any content. Basically none will be returned. And whenever it gets a new input agent task, it will add those to the packets. And whenever packet size reaches this n value, that which is the mux size, it will return that packets, and it will clean up that packets. So this is what the muxer will do. And we have an signature here, one signature, DSP aggregator signature. So you are a Book My Show movie aggregator. Your objective is to produce a clean list of eligible movie recommendations. Some rules are given. So exclude genres, special instructions. So negative constraints are the highest priority. If movie belongs to an exclude genre, and it must be removed from the consideration, even if it is a must-see movie. So that's very important. And also some critical instructions are given here just to find out. Basically, it has to mix and match several things. One is from the movie preferences, one is from movie calendar time slot availability, and it also has to check the movie availability in theaters, what movies are available, what genres, at what time, all those details it has to do, right? So we have given a curated system message. So at the end, we are expecting a all valid action and a reasoning for it, like whatever it has selected, right? So we require a reasoning also as an output field from it. So aggregated findings, this will contain the content of a preference agent as well as a calendar agent. So they are aggregated as a mux data now, and like that's what here mentioned, calendar and preference data, it will be muxed and it will be given in the aggregated findings. And theater matches, so this is basically the movie availability. So yeah, so this is the theater matches, PVR cinema. This is the location. These are our movies are available in the different screens, and these are the duration of show times in those screens. And this is another movie animation genre, and show times are given here, duration is given here, because this duration will help us in identifying when this movie will end, so that it can mix and match the time slots and the overlap it can identify. So all those details are available here. So and also it is not just about simply, it will not simply provide all these theaters details. It has to again make sure that send only the theaters which are matching with the preference timings, things like that, like the calendar slots availability and all, right? So if this time is not good, so it should not send these details to the LLM. Only let's say if this is alone is matching, so it should send only this time, not this time. So it will basically curate properly, like it will give a structured content that I will show in the later stage. So this is second signature. I'll explain the second signature later. So we have a Book My Show module, we have a aggregator, which is a chain of thought, and we have a predict. So right now I don't require a chain of thought for the confirmation. So the confirmation signature here, I'll explain it later. So chain of thought is required because we want a reasoning for why the LLM has chosen that. So Book My Show agent, we have rest all remains same except few things now newly introduced, because as I told, we require a human in loop for the Book My Show agent. So for this reason, we require a base URL, poll interval, and a max wait time. So max wait time is something that if you don't give in your user input within that time, the polling will not happen again, so it will be closed. So known agents, which I explained again already. So for movie theater showtime aggregation and booking, so this is the query that I have providing, and I'm initializing the his client as well, and also I'm initializing the muxer. By default, I'm mux size, I'm getting it from the registration persona config parameters mux size. If not, they are dynamically configured as well, because the first agent will reconfigure it. So in the get muxer, I'm returning the object of this self.muxer. So that core main core.main will take this muxer into consideration, and let's go to on data now. In the on data, so we have a prepare inputs. What it does is basically gets the aggregated findings, it gets the calendar slots, it gets the preferences. So let's see the prepare input function. So prepare input function, we have a payload processor, like basically given an agent task, it will break down the tasks. So from this we are trying to collect the calendar slots, movie preferences, any findings, if any special findings or keys are present, right? So we are just getting those data from this particular after doing a JSON load, because we have done JSON dumps there in the other agents. We have to do a JSON load here. Sorry, we are doing a JSON jumps in JSON dumps in this muxer here. So JSON dumps deep copy, somewhere we are doing JSON dumps here, so that's why we're doing a JSON loads. Okay, so so we got the calendar slots, preferences and special instructions, and that will be returned from this particular function, where aggregated findings, which is a complete text, the complete text, like the special findings, whatever is there, right? So that will be sent as aggregated findings. Calendar slots and preferences will be also sent from this function. Then this is one other function where match theaters, because we have a calendar slot, the free slots available, the data we have, and the preferences also we have. So in the calendar slot, let's say you have a, so this whole slots are available, right? But all this data will not be available with us right now. Let's say movie preferences is Friday and Saturday. So only for Friday and Saturday slots are collected, and because that is coming from the calendar data, right? So only those slots are coming, and that will be given to the match theaters. And preferences, so related to genres or days preferences, all those details will be in the preferences. So for that, we let's see this function. So match theater, what it will do. So basically match theaters, it has to basically identify what we have a movie availability, which is basically this movie theaters, what movies are available in which theaters and what timing. So it has to mix and match the this movies availability, and also the calendar slot free time slots, and also preferences. Basically it has to identify the overlaps. So here let's say movie availability, so from the movie availability I'm taking one theater and I'm taking one movie from it, and from there I'm checking a title. If title is in preferences must see, so preferences we have must see titles, right? So if it is available, it will directly take that. If not, it will go for a it will not choose that. So here duration, why duration? Because we have to mix and match the start time and end time with the time slots, user time slots. So we are collecting the movies duration timestamp, and a show time, start of the shows, like what is the start of the movie and when it is going to end. The end is nothing but start of the movie, and the duration, so that is the end. So with that, we are trying to check all the slots available in the calendar slot, and we are checking whether there is an overlap or not. So if overlap is there, we'll add it into the matches dictionary, matches list, and we are providing this kind of keys, like what is the theater, movie, genre, time, duration, and which day it is. So we are basically, then we are collecting all the possible combinations which is which is coming out of movie availability, as well as user preferences, as well as user calendar time slot. Then we are creating final formatted text, what is match and what is show time and what is duration from those matches, and that will be sending it to the from this particular function. So basically that will be fed as a input to the LLM. So now we'll call the execute worker. We'll give that aggregated finding text, which is coming out of this particular function, and a matches text, which is nothing but the theaters, the movies that have matched the users preferences and calendar slots. So that will be given to the execute worker, where execute worker will talk to the LLM by giving those input, and DSP will curate that such that we want whatever we want, right? It will collect those outputs. So final list raw, so it will basically just clean, we have all valid options as a in the signature. We have all valid options and we have a reasoning, so it will collect that. So final list raw and reasoning will be collected, and if any thriller, since we have given some instructions related to thriller, so if thriller is present and it is in exclude, so we are just saying exclude genres as a thriller. And finally we are collecting the final list of movies. So that final list will be like it's logging here, and also we'll be sending those to the his client. So interface, human system, so human in service. So the submit and wait, where we are giving some instructions like choose your movie, the final list of movies that is user is supposed to select, and the reasoning. So let's say you have a 5 movies shortlisted. In that, the reasoning might say, hey, 2 3 movies are we are not selecting because of this reason. It might say that. And the final list, so out of 5, 3 are not good and only 2, so only 2 will be available here. Basically this will take care of avoiding the exclude genres movie. Then we'll be sending it to the user, and it will wait for the maximum timeout, and if user responds something within that, so it will get this, it will get from this obj.response-data.get user choice. This user choice is the key that we need to send when you are hitting from the his client, sorry, the our dashboard. So user choice is picked, and that will again now send to the one other function. So in this function, what we are doing is we are sending the final list of movies and user choice raw, like whatever the user has chosen, right? User can give it in any words, or it could be a number. Let's say you have given 2 movies, he might select one as a input, or he might say I prefer this theater, I prefer this movie. Any raw string can be given by the user. So that's why we are sending that raw string and also the list of movies that we have to this particular function. This particular function will use the one other module, the self dot module, where we are the module here is nothing but the yes. So if you are sending the so we have a conformator, right? So let's see the signature first. So you are a precision booking selection agent. Your task is to identify exactly one movie option from the original options and match the user feedback. So that's what this instruction is. We are giving some critical instructions here to match it, and we are using that conformator now. So let me just show you. So run confirmation model.context self.module original option and user feedback. A user feedback is given. So here there is no user feedback. Here we are giving a user feedback. So if user feedback is there, so this module will do an if and else condition here. If user feedback is available, it will do the if user feedback is available, it will use the self.conformator, and if user feedback is not available, it will use the aggregator. So since feedback is available, it will go to the this conformator's DSPy predict function, and it will select one movie and it will return that movie, and that movie will be written by the it will be written by the again we are just cleaning the final output, and we are sending that output to the as a response to the user's query. So this is the code. We have seen a human in loop system, how it is integrated. So before that, I just have to explain the client side as well of a human loop. So we have basically 2 endpoints, so fetch URL and submit URL. So whenever a human in loop pushes the data, we need to fetch it. So we have a fetch URL. It will endpoint will look like this, his base URL, which is basically some URLs where the cluster is running, and this is the root subject response by subject ID, and you need to provide a subject ID here. So I know that this is the subject ID, right? So I have hard coded here because it is a book my show agent. Subject ID is given here. This for fetching, so you have to do a request.get for the fetch, and if it is success, you have got some data and just pass that data. So during submission time, so you have fetched it, user will press something, you collect that data and you do it a submit URL template. So again, it's a his base URL. You have this root subject responses, you have to provide the ID here and the set response, and you need to do a URL the post operation. So payload is like this this is response data, the user choice. This keyword has to be there because that's what I was trying to explain here. We are collecting a user.choice. This last agent, user.choice will be selected. I would have explained it already. Yeah, user.choice, user underscore choice is required. So that keyword, in that keyword I am sending, so any keyword you can, it's not, we are not restricting, so only this key and this key are the two main key that has to be available, and the user choice is your option. You can provide anything there. And status completed has to be sent, or else what happens is the status will be in pending state. So if status in pending state, again if you are querying it again, right, so again you will get the same query. So the same content you will get. So it's better you update the status equal to completed as well. We are not updating it from our side. You need to send it status completed, so then only we'll update this into the DB. So this is how to submit the response. We can do with the plain terminal commands as well for fetching and submitting, but right now I have created a small app in a Streamlit. So let's now try to run a demo. So I have run already this all.bash. What it will do is basically deletes if the registers, the agents are running, then build the Docker, push the Docker to the registry, register the unregister the agents, register the agent, deploy the agent. So that these are the tasks done by this all.bash. I have already done it. And to run the Streamlit app, I'll run this kernel. So basically this will run in a background process. It will run as a background process. So let me just run this. So it has run. Let me just refresh this 8051. Yes, this is the dashboard, a simple dashboard. So let me just show you the pods. Okay, so these are the 4 pods available. Sorry, 4 agents: book my show agent, planner agent, and 2 parallel sub agents: calendar agent and preference agent. And so let me run the inference request. So I'll show you the inference request and output first, because within a few minutes his client will time out. So let me run it and let me wait in the his time dashboard. Yes, so his dashboard got the output. So it has selected this movie, Dune Part 2, genre sci-fi, theater Cinepolis, Saturday. Time slot is 17 to 18:59, duration 109 minutes. It has this. It is initially finding these movies, but it has excluded few movies because it's in a thriller. Why it is so? Because we have given up some preferences. If I watched a thriller last week, I don't want to watch one this week, because I have watched the Grey Man, which is a thriller movie. I don't want to watch it. So this is the last week. These are the 2 movies that I have watched last week. So I don't want to watch a thriller again. So that's why it has excluded. So let me give only one movie it has selected. Let me give it as 1. So let me submit the choice. Response is submitted. And let me go to the, yes, it has, I want to watch a movie. This was the input. Only plain vague, I want to watch a movie is given. And it has selected the Dune Part 2, and these are the theater. It has selected Saturday time slots. So let us check the log of each agents. So yeah, the input has received job inbox. I want to watch a movie, and so what it does, it has to basically break that task to text, reasoning, plan, calendar query, and preference query. It has to do that. So let us see what it has got. So plan, use the calendar agent, find schedule availability. In the plan, second point, use the movie preference agent to find the user movie preferences, combine the information to create a movie plan. And now again, this is the plan, and I have not printed the other 2 outputs, but right now we have to send the mux size equal to 2 to the last agent. So it is doing that right now. It has communicated the mux. Let us see the last agent. Here is the last agent. Let me just check job inbox, find a user movie preference. I want to watch a movie, communication. Okay, sorry, this is not the last agent. Maybe let me just check this is the agent. Oops, sorry, this is the last agent. Yeah, so the mux size is received. Let me just, yeah, the mux size is received, and it will set up that its mux size is received, and it will be ready for the next task. So it has been set up now, and the next task is received. So before going to the next task, let us go to the this agent. Yeah, find the schedule availability for the movies, and the other sub agent is find user movie preferences. This is the preference agent. So it is talking about the preference movie preferences, and this is talking about the movie availability, sorry, the users free slot availability. So in the free slot availability, it is trying to these are the inputs given to the LLM. I want to watch a movie, find a schedule availability for movies, calendar data, calendar preferences, and it has to collect the output like this. So what all chosen days? It has chosen Friday and Saturday based on the user's availability and the user preferences. Formatted availability Friday from this time to this time, and Saturday 12 o'clock to 15 o'clock and 16 o'clock to 22:00. So these are the three refined JSON outputs. So we wanted three outputs. One is chosen day, formatted availability, and a refined JSON. So it has given those three outputs. This will be sent to the last LLM, and also here is the output of a preferences, movie preferences. So movie preferences, it has given a structure like this. Preference summary: must see movies, Dune Part 2, The Batman, exclude genres, thriller due to recent past history, horror, musical. So I would have given only these two in my preferences. I don't like horror and musical, but this has also been included because in the exclude genres, because it is due to recent history. So preferred genre sci-fi, special logic, exclude thriller due to recent history, do not prefer kids movie. I would have given this information. Prioritize sci-fi movie if more than a week since last sci-fi movie. So these are the some special instructions. So this will come out of the preference agent, and now the first after the mux input, it has received one input. Maybe it is from the must see. So it is a preference input, and the one other input is coming out of the slots availability is a calendar agent. Then it is mixing and matching the availability. So it has calculated basically these are the three matches available for the movies. Then at the end it will send the so these are the final theater matches. So basically it has responded with the this output, and now that output will be passed and sent to the user for his client. And once his client sends the output, once he selects the output, so match one. So yeah, sorry, before that, yeah, the movie is in that still only the one out of these three movie, only one is matching, because the other two movies fall in thriller category. Batman is in the genre thriller, which is excluded. Therefore it is excluded. Match to the movie Batman is also in thriller, which is also excluded. Only the Dune part is selected. So that will be sent to the his client. So his client will as soon as his client responds, the final signature, which is a confirmation signature, will be called. So original option, user feedback, final selection will be called, and once the signature is called, a finalized selection will be done and sent to the UI to the user. So this is it. So we have showed you how his HIS, or human in system, human in loop, or human in system, human in loop service to be used in AgentGrid. So basically in human in loop, so the client or the agents will send the information to the user. User can do a polling, basically a request.get, request.post. So after polling, you have to submit the data to back to the agent. So agent will collect that and finalize its content. So so this is how the human in loop system works in AgentGrid. And to remove the agents, you can run this cell, and to close the his module, you can interrupt this kernel, so that his module will not run now. Just refresh. So it's not running now, it's closed. So I have deleted all the pods as well. So that's how we can run the agent human in loop pattern in the agent grid. So human in loop pattern is essential for high stake decision like payments, bookings, or code reviews. So final confirmation if you require it from the human. So this kind of system you can use by combining the speed of parallel agents with the reliability of human judgment. You can build the trustable and robust agentic systems. So I hope you like the demo. If you like it, so please don't forget to subscribe and keep supporting us. Thanks for watching.